This lesson is on using the intercept form of a quadratic equation, and we will be talking about how to change forms of your equation so that you can tell how to graph it and what some other information will be. So the first thing, let's get some definitions. The standard form of a quadratic equation is f of x equals ax squared plus bx plus c, and we've already dealt with that. But when it's in that format, then that's what's called the standard form. A is the coefficient of the quadratic term, and b is the coefficient of the linear term, and c is the constant term. And so we've used this before with quadratic formula where we have those coefficients, but we also know that we're not really able to tell too much about the graph just by looking at it like that. So that's what we'll be talking about today. The x-intercepts, if you'll remember, of the graph of a quadratic function are the points at which the y is equal to 0 and it intersects the x-axis. So if you think about the picture, if you have an x-intercept, that means that it's where it's going to be touching the x-axis, and at that point, no matter where it is, you're going to have something and then 0. So that's what the y, or the x-intercept is. The y-intercept is where x is equal to 0, and it intersects the y-axis. So if you think about, well, that's a really bad picture, but anyway, if you think about where it intersects the y-axis, that point is going to be 0 something, and so that's where x is equal to 0. So that will be the y-intercept. When we have a quadratic function, the y-intercept of a quadratic value is the c value when you have it written in standard form. So if we had something like 3x squared plus 2x minus 5 equals 0, even though right off the bat we can't tell too much about it, I would know that the y-intercept would be at -5. So 0, -5 would be the y-intercept. And so that's what we can tell from that. The equation of the axis of symmetry, we talked about this a little bit last time in the lesson. The axis of symmetry is that line where that's symmetric across that. And so we also know that that's the x-coordinate of the vertex. So if I have a quadratic formula or quadratic equation and I'm graphing it and the vertex is, say, at 2, -2, I know that the axis of symmetry is going to be this vertical line that goes through the vertex. And so one of the things that I can do with a standard form equation is if I will take -b over 2a, that will tell me where the axis of symmetry is, or in other words, it will also tell me my x-coordinate of the vertex. You'll recognize -b over 2a as being part of the quadratic formula, and we learned before how the b squared minus 4ac is what's called the discriminant. And this is the rest of the quadratic formula, and that's going to help us find the vertex and do some other things that are interesting with that. So this is something you'll need to make sure that you remember. Like I said, when you do -b over 2a, that gives us the x-coordinate of the vertex, and so to get the y-coordinate, you would plug this in for x, and what you would get out is your result. So that's what this means down here. This is your input, and then this is what you get out. So f of that number, whatever it is. So we'll talk about how to do that. Okay, so first example, f of x is equal to -2x squared plus 4x plus 3. Let's talk about the things that I do know from that. I do know that this is going to be the y-intercept because that's what it says in standard form. So we're going to have 0, 3 will be our y-intercept. Some other things that I know that we'll kind of make use of in just a minute is because the leading coefficient is negative, I know that my graph will be opening down. There's going to be a reflection. So I may not know how far, and you can't just say, well, it's going to be stretched by 2 because of the other things that are in that equation. It might not be exactly what you think, but we do know it will be reflected. So what we're going to do is we're going to find the vertex, and then we're going to talk about the max or the min and sketch the graph. So to find the vertex, we're going to use the -b over 2a. So -b would be -4 over 2, and then a is -2, so that's going to be -4 over -4, which is 1. So the vertex is going to be 1 something. So how do I find out what the something is? Well, I take 1 and I plug it in for x. So it's going to be -2 times 1 squared plus 4 times 1 plus 3. So that's going to be -2 plus 4, which is 2, plus 3, which is 5. So 1, 5 will be my vertex. Okay, so with that information, I can start making my graph. So let me put an axis here. Okay, so we're going to start by graphing the things that we know. I know the vertex is 1, 5, so I'm going to put that point. And I know that the y-intercept is at 0, 3. I also know with a parabola that there is symmetry, so I also know that there's going to be this point right there, 2, 3, as part of my parabola. There are some other things that I could find out, and we'll do this in later graphs. I could solve for x and find the x-intercepts. I could do that by solving and find out, like, they're going to be somewhere along here. There is going to be symmetry involved, so if I found one, I could figure out the other one. But for right now, the only thing that we have to do here is do this much. So that's how I'm going to draw my graph. The other question I need to do is a max or min, and there is a max on this one. So for right now, that's all we're doing. Okay, number 2. If you want to pause this and see if you can do parts of it or all of it, then come back and we'll see if you do it right. Okay, to find the vertex, we are going to, actually I'm going to interrupt with y-intercept because that's the easiest one. That's 0, 5 because of that right there. The vertex, I will do negative b, so it's negative 11 over 2 times 2. So it's going to be positive 11 fourths. So I know that my x-coordinate for my vertex is 11 fourths. Then what I'll do is I will plug in place of x, I will plug in 11 fourths. And I'm going to go ahead and keep it as a fraction. With a number like that, I don't have a huge problem with a decimal, but because of the way I am, I'm just going to keep it as a fraction. So I'm plugging in 11 fourths and squaring it, get 121 over 16, multiply by 2, minus 11 times 11 fourths, and then I'm going to add 5, which is 20 fourths at the end. So, in the end, negative 81 over 8. And you can use your calculator to help you out with that a little bit, but hopefully you know how to do it anyway. Okay, so the axis of symmetry is just going to be x equals whatever my x-coordinate was, so 11 fourths. The x-intercept, that's where I'm going to need my quadratic formula to solve it. So I'm going to solve using the quadratic formula. So 11, because negative 11 plus or minus the square root of 11 squared, minus 4 times 2 times 5 over 2 times 2. So after I do the quadratic formula, I get the answer is 5 and 1/2. So those are my two x-intercepts. So make sure that you write them as two separate ones. You can write them as a solution set. So 5 and 1/2, but just don't write them as an ordered pair. Okay, so as far as graphing this, I know my vertex is 11 fourths, which, we're going to need like a decimal approximation to help us out with the graphing. So 2.75, and then down 81 eighths, which is down about just a little past 10. And then my y-intercept is at 0, 5, and my x-intercepts are at 5 and at 1/2. And so that can help me draw my graph pretty accurately. And so I can tell also that there is a min. Okay, number 3, you should pause the video and you should go ahead and work through all of these parts of it, and then start the video again and I'll have all of the answers up. Okay, so the vertex is going to be 4, 6. The y-intercept is 0, negative 10. The axis of symmetry is x equals 4. The two x-intercepts, 4 plus or minus the square root of 6, I went ahead and put the decimal approximations. I'm not going to put those where I'm asking for the answers, though. But that's something we need to do for when we graph it. So 4, 6 is right there. The y-intercept is 0, negative 10. Okay, right there. And then we're going to graph the approximate locations of the x-intercepts. So this is the graph that we have. With the axis of symmetry, if we are going to put that on our graph, we do that with a dashed line. And so if you go back to the previous problems, probably should have written that in there, but there's the axis of symmetry. We do that with a dashed line to show that it's not actually part of the equation, but it is part of the graph if we want it to be. So as far as will I require that? Not necessarily, but you do have to know the axis of symmetry. Okay, now we're going to find the equation of a quadratic that has a vertex of 2, -4 and a y-intercept of 4. So if we take the equation ax squared plus bx plus c equals y, then I know from what we just said that c is equal to 4, so I can put that in there. And then I also know that -b over 2a is equal to the x-coordinate of the vertex, which in this case is 2. So I can solve this for b. And you'll find that this becomes kind of an intense system of equations that we're going to be using here. So I'm going to take this b equals -4a. I'm going to plug that in for b right there. So ax squared minus 4ax plus 4 equals y. And then I'm going to take my 2 and my -4 and I'm going to plug them in for my x's and y's. So I'm going to have a times 2 squared minus 4a times 2 plus 4 equals -4. Okay, now we can solve it for a. So I'm going to have 4a minus 8a plus 4 equals -4. So -4a is equal to -8, and so a is equal to 2. Now I can take that and find b. So b is equal to -8. So I can take both of those and plug them in to my equation. So I'll have 2x squared minus 8x plus 4 equals y, and that's the equation that has a vertex of 2, -4 and a y-intercept of 4. So let's go to the next problem, number 5, and probably pause this video and see if you can do what I just did, and then turn this back on and see if you get the right answer. Okay, so you should start with ax squared plus bx plus c equals y, and then you're going to replace your c with your y-intercept, which is -69. So we'll write minus 69. And then we're going to say -b over 2a is equal to 5. So -b is equal to 10a, and so b is equal to -10a. We're going to put that up here in place of b. So ax squared minus 10ax minus 69 equals y. Then we're going to use our x and y's to replace in our equation. So we're going to have a times 5 squared minus 10a times 5 minus 69 equals my y is 6. And so now I can solve for a. So -25a is equal to 75, and so a is equal to -3. So we're going to take that and find b. So b is equal to 30, and then I can take both of those and put them up in my equation. So a x squared plus bx plus c equals y, and so that would be my equation. So if you didn't get that, then go back and look and see what happened. Okay, we're going to be talking about some story problems, and as we've talked about before, when you're talking about story problems, you're dealing with gravity. A lot of times quadratics are following this path that's described by a quadratic function, and so remember that the -g right there, that is gravity divided by 2, half of gravity, and then the v sub 0, that's the initial velocity. So what is the speed of the object when it starts, and h sub 0 is the initial height. We've talked about initial amounts before, and so that's what you're going to be using whenever you're using a quadratic type situation. So if we go to problem number 6, it says Jamie jumps off a 12-foot high diving board with an initial velocity of 12 feet per second. So first of all, I'm talking about feet per second, so I'll be using the -16 instead of the -4.9, because 4.9 is for the meters. I like to draw a picture, so get ready for some great artwork here. We've got Jamie here jumping off the diving board, and just to show her path, it's going like this, and so you can see that it's going to be like a quadratic type situation, although really it's only good for a certain amount of time, because obviously she didn't like start from, down here below the water and come up and then keeps going forever and ever. That would be silly. So we're going to describe the path that she'll be going. And so it says that her initial velocity is 12, and so I know that v sub 0 is equal to 12. And I also know that her initial height is 12 because she's 12 feet above the water. So this right here is 12, and that's the initial height. And so what I'm going to do is I'm going to put that information into the equation. So negative 16t squared plus 12t plus 12 is equal to her height at any given time. And so then I'll find out when does she, well, what is the highest point? So the highest point is going to be the vertex, so that's going to be up here. So I'm just going to use that to find negative b over 2a. So negative 12 over 2 times negative 16. And so I can find out what that is. So I find out that at 0.375 seconds, so that's my x coordinate, so that's the amount of time it takes. So 0.375 seconds after she jumps off is when she'll reach the highest point. But how high is it? So I would have to plug this back in for t because that's my time. So I'm going to plug that back in. And I find out that it will be 14.25. So she's really only jumping like 2¼ foot off the diving board, so she's not jumping very hard. But that's how high. So that answers the first question. The highest point she reaches is 14.25 feet. And then it says how long until she hits the water. So what I want to know there is I want to know when is her height equal to 0. So I'm going to replace this h of t with 0. And then I will solve, probably on something like this, I'd probably just use the quadratic formula. And so I'm going to get that in the quadratic formula and solve that. Since I'm solving for t and I notice that all of my numbers are divisible by a common factor, I'm just going to make the numbers a little bit easier. I'm going to divide everything by 4. So I'll have negative 4t squared plus 3t plus 3. And since I'm just solving it, it's going to come out the same. It's just going to make my numbers in my quadratic formula easier to work with. Okay, in this real life situation, I'm going to use decimals because that would make more sense than giving a radical for the amount of time. So when I put this in, I've got 2 answers. One of my answers is going to be this point over here before she started, which wouldn't make any sense, so that will be an extraneous solution. The other one that does make sense is going to be the 1.32 seconds. So when I'm putting this in my calculator to get a decimal approximation, that's how long it's going to take her to hit the water. So if you want to pause this and go back and examine and make sure that you understand what just happened, that would be a good idea. And then go to the next one. For number 7, Tom and Jerry are trying to throw a ball over the top of a 25-foot high building. And so you've got this building. They're trying to throw this ball over it. Okay, now Jerry is only 5 feet tall, so the ball isn't starting on the ground, it's starting with Jerry's height. So it's 5 feet off the ground, that's the initial height. And the initial velocity is 30 feet per second. And so will he be able to clear the building? So I want to know, is the height going to be at least 25? So what I'm going to do for Jerry is I'm going to say negative 16t squared plus 30t plus 5. Is that equal to 25? Now, if I get imaginary numbers, that means it's never going to happen. If I get real numbers, then it will happen at a certain amount of time. So I'm going to get everything into standard form. And everything here is divisible by 2, and that just makes my quadratic formula easier to use. So I'm going to put that in my quadratic formula, and so I'll let you work that out. But when I get this all in there, if you want to put that in your calculator, what's going to happen is you're going to get 2 imaginary solutions, and that means that it's never actually going to happen. So Jerry will not be able, at this velocity and this initial height, be able to clear the building, and so that's why. Now if you take Tom, who is 6 feet tall, so his initial height is changing the situation, and he's throwing the ball with initial velocity 35 feet per second, so he's throwing it a little bit harder. So a couple of things are going to change. The building's not changing, but that initial height and the initial velocity are. So I'm going to change this to be 35, and then this is going to be 6. And so then I'm going to do the same type of thing, and I'm going to move everything to one side. So I have 0. I'll put it into the quadratic formula, and this is what I end up with in the quadratic formula. And that's going to equal negative 38 over negative 32, which I would simplify, and negative 32 over negative 32. Both of those are real numbers, so Tom's ball is going to reach 25 feet at 19/16 seconds. That would be over here, I guess, a little bit past 1 second, and then at 1 second. And then in between that, it's going to be above 25 feet. And so that's going to be yes, he will be able to reach that height. And then the last question, Deb gets the idea to make bracelets to sell to earn money. She has her brainiac friend Napoleon figure out that the profit of her endeavor is represented. A lot of times profits will be represented by quadratic equations because you make a profit, and then at a certain point you're not making a profit anymore because the cost is not worth it, or you're not selling enough, or the demand is not enough, or whatever. X is the number of bracelets sold. So how many does she need to earn to sell to make a maximum profit? So since we're talking about maximum, we're talking about the vertex. And so then it says, what is the maximum profit? So the what is part, that's the Y value. And how many does she need to sell? That's the X value of the vertex. So I just need to find the vertex. So the negative B over 2A. And so that's negative 40 over negative 8, which is 5. And so 5 is the maximum amount of it's the number of bracelets that she'll need to sell to make the maximum amount of money. So what she's going to sell is 5 bracelets, and so then how much would she make at that point? So you're just going to plug in 5. So negative 4 times 25 plus 40 times 5 is 200. Minus 2, and this takes into account things like how much the initial cost is to make the bracelets and so on. And so she's going to make, looks like $98, and that's the most that she's going to make. After that, then, the demand will go down, or it will cost more to make more, and it won't be worth it. So that answers the first question. The second question is, when will Deb break even? Breaking even means that you make the same amount of money that you spent. And so what we're going to do is we're going to set this equal to 0, because that's what breaking even is. And so then we can just use the quadratic formula to solve that. And so when we put this in the quadratic formula, this is what we get. And that over 2 is just over the 7s. We're at 2 because I simplified the rest of it. That comes out to be approximately 0.05. and 9.95. Well, you can't sell 0.05 bracelets, and you can't sell 9.95 bracelets. So she's going to have to sell between 1 and 9 bracelets. If she sells 10, then that's going to be past the break-even point. If she sells 0, that will be past the break-even point. So if we have something like this, what we're talking about is we're talking about the positive region of the graph, and that's what we're talking about. Okay, so that takes care of the notes for this section, and we'll do the assignment in class. If you have any questions, come and see me ahead of time, and then we'll do 6.3 in class.